Hello everyone, my name is Fred Rispoli and I'm coming to you from Stony Brook University in New York, and in this video we're going to talk about using R in basic data analysis. An outline of this video is we'll begin by talking about the iris dataset. We'll use this to create histograms, stem and leaf plots, box plots, and basic statistical functions. But before watching this video, please download R and RStudio onto your computer. Directions can be obtained using a Google search, or perhaps you could get help from someone who is familiar with R. Now, R is a language and an environment for statistical computing and graphics. It was developed at Bell Laboratories, or formerly AT&T, now called Lucent Technologies, by John Chambers and colleagues. R provides a wide variety of statistical, both linear and nonlinear modeling, classical statistical tests, time series analysis, classification, clustering, and other graphical techniques, and is highly extendable. As I said, R is available for free and can be downloaded. It also has many packages that can be added. The iris dataset was first discussed by the famous statistician Fisher, and it gives measurements in centimeters of the variables that we'll call sepal length, sepal width, petal length, and petal width. Okay, and these data values are obtained from 50 flowers, and these come from 3 different species of the iris. The species are the iris setosa, versicolor, and the virginica. So you can see here is our list of the 5 variables. There are 150 data points for each. These first 4 we would call numerical variables, and the species variable is a categorical variable. And again, this data set is built into the R language as a sample data set. So once you're up and running with R, to view the iris data set, we could use the view command. Now this is capital V and then IEW, and we enter iris. And you should be able to see the iris data set if you're using RStudio. If we want to produce a histogram, we could use the hist command, HIST, and then we enter our data set, iris, followed by a $, and then we have the variable name sepal.length. So this will produce a histogram that you see below, right? Straightforward histogram. The height of the bars represents the frequencies. So let's try an exercise. Stop the video and try to produce a histogram for sepal width using R, and then one for petal length using R. Solutions for this exercise are given here. You can see on the left there's a histogram for the sepal width, and on the right the histogram for the petal length. So you might be wondering, how do we get these from R into a PowerPoint or Word document? Well, we could import charts from R, okay, using the following sequence. So if you produced a histogram in RStudio, look for the export button. Okay, we click on export, then click on copy to the clipboard, and click one more time on copy the plot. Then go to your Word or PowerPoint document and use the typical paste operation, and this will allow us to put these charts right into our PowerPoint document. Pie charts can also be made very easily in R. You need a table of data, okay, and as an example, we could create a pie chart for the species variable. Remember, this is a categorical variable with the 3 categories. So if we enter pie, then use table, iris, followed by the $, followed by species, this will create a pie chart that we see here below. And each piece of this pie chart represents the number of flowers that fit into each of these species categories. Another way to get at data in R is to enter data by typing it in. Okay. For example, suppose we have this list of midterm scores given below. You can see this is a fairly large list. So if we want to create a variable that we'll call midterm, we can start out typing out the word midterm, set it equal to C. This is the letter that we used when we're creating a variable. And then we type in 30, 34, 38, and so on until we reach the end of the list. So here we would type in all the values from the previous slide. Okay. There are other ways to get data into R, but we'll leave that for a later video. Now, to create the histogram for midterm, we use the hist command, H-I-S-T, and we include midterm inside the parentheses, and we produce a histogram that looks like this one over here on the right. R can also make stem and leaf plots. So to illustrate this, let's say we have exam scores of 26 students and we want to construct a stem and leaf plot in R. So you can see here's our data set. So first, we'll create a variable that we will call A and enter the data manually, right? Similar to what we just did in the previous slide. So we set A equal to C of 55, that's our first data point, comma 61, 94, and so on. So we type in all 26 of these values. And then we create the stem and leaf plot using the code stem with an A in parentheses. The output looks like this. Now here, the output will not be a chart, right? When we created a histogram, we had a chart, but here you'll see the output in the same area where you enter your code in R. We could highlight that output and hit copy and then paste it into our PowerPoint or Word document. And you may have to reformat it a little bit. I had to reformat this, but this is our stem and leaf plot. So now the 5 here on the left, that would be our stem, and then we have leaves 5 and 9. So this sort of represents the values 55 and 59. In the second line here, we have a stem of 6. The leaves are 1, 2, 9, 9. So this would represent the values 61, 62, 69, and 69, and so on. So we have a nice summary of this data set, and moreover, we can actually recover all the original data values. So, once again, let me ask you to stop the video and try this exercise. Produce a stem and leaf plot for the iris variable that we called sepal length. Okay, you could use this code here, and notice that I've added sort of a new wrinkle here. We'll include the scale and set it equal to 0.5. Now, scale is used to expand or reduce the size of the plot. So when we carry out this command using R, we should end up with output that looks like the following. Okay, you can see by scaling with 0.5, the length of each line is approximately half of what it would be without the scale. So on this first line, I'm going to get the values where the ones digit would be anything from 0 to 4. And then you could see if it's 5 through 9, that goes to the second line. So here we can recover the values, right? This 3 represents the value of 43, and we have 3 44s. Then on the next line, I have a 45, 4 46s, 2 47s, and so on. Another useful tool that's easy to create in R is a box plot. So if we wanted to create a box plot for the exam scores given in our variable A, we could use this box plot command, this box plot with A in parentheses, and we produce this chart, and we could take the chart and export it right into our document. An advantage of box plots is they're very good in comparing two different variables that have the same scale. Okay, so if I had two variables, A and B, I could use this command boxplot A comma B, and that'll produce a side-by-side box plot. So for example, suppose that B contains scores from another exam, and we want to compare the scores in A to those in B. So let's create our variable B. We'll type in the data here. So here we use this C notation. So I have C, we have these data values, and then we create a side-by-side box plot, and you could see the output over here. So we could look at this and compare. You could see that the first set of scores, the A scores, have a narrower range. They have a higher median, and just overall, they're a little bit higher than the second set of scores. Another way to create box plots is if you have a categorical variable and you want to use those categories to help build your side-by-side box plot, we can do that. So for example here, if we think of the sepal width variable, we could use the species variable for our categories. So we would enter this, and then we tell R that we're using the data set equal to iris. So here now I have my side-by-side box plot based on the three species. And one more thing to note here, you could see that there's this small circle here. Okay, so that's used to indicate that there's a value here that is an outlier. So you'll see this with most statistical software programs. Whenever you see a box plot, you might see a circle outside the box plot, so that indicates an outlier. You also may see an asterisk used the same way. Finally, we'll talk about the basic statistical functions in R. So these come up all the time. We have the mean is just simply the word mean. Variance, VAR, standard deviation is simply SD of A. Or if you have the variance, you could just take the square root of the variance. Okay. We have MIN for the minimum, MAX for the maximum. And if you wanted to know the value of a certain percentile, okay, we would use this quantile function. So for example, if I wanted the 60th percentile of my variable A, I would use the quantile command A, and then in place of P, I would enter 0.60. So here we're entering the percentile expressed as a decimal. So as an example, suppose we wanted to find the mean, the standard deviation, and the 75th percentile for the sepal length variable in the iris data set. So for the mean, you can see we use the mean function, iris, $CEPA length, and our output would be 5.843333, and of course this is in centimeters. For the standard deviation, I'm using just SD, the same variable here. Our output is 0.8280661, and again, centimeters. And for the 75th percentile, we use the quantile operation. We enter the variable we're interested in, the CEPA length. And for the 75th percentile, I enter 0.75. And you could see our output here would be 6.4. So that represents the 75th percentile. Okay, we've reached the end of the video. Thank you for watching.